Yes. Good morning, everyone. Am I audible? Okay. Fine. So I'll wait for 2 minutes for everyone to join. Then we'll start the lecture. Also, I'll be sharing an attendance form. So this is your just a minute. You can share. This is the attendance form that I'm sharing. So mark your roll number in this attendance form and submit for attendance. Okay. I suppose everyone has joined. So let's start our lecture. So in the previous lecture, also let me know, am I my voice is not breaking, right? It is clear. Okay. So in the previous lecture, we started our discussion with regression tree. We discussed what is the difference between a regression tree and a classification tree. In your regression tree, you will be predicting continuous values using the decision tree, right? Then later on, we started our discussion with ensemble learning models. Okay. And why are we choosing ensemble learning models in the case of decision tree classifier? So one of the reason that we sorted out in the case for ensemble learning model is uh, while a decision tree can provide you high variance, right? For different, if you for example, just let me share the screen first. Okay. So in the case of normal decision tree classifier, it is possible that it will provide you high variance. Okay, the variance will be very high. So for example, this is your training data set that you have. And if you divide the data set into two parts and you pass this two data set into different decision tree classifier, then it is possible that the two decision tree classifier will give you different results. Okay, so it will give you high variance. Decision tree is actually a high variance model. Okay, so in order to reduce this high variance, there is a possibility that we saw an example. We saw an basic example, an analogy that the wisdom of crowd is much better than individual opinions, right? Okay, so for example, we saw the experiment that is performed by a particular scientist where they are trying to predict the weight of an ox. Okay, weight of an ox is being predicted, but where for example, if a single individual opinion is calculated, then it is possible that it might be far away from the actual weight of the crowd. But when weight of an ox, but when the weight of an ox was predicted using the the multiple opinions by the crowd, then it was found out that it was approximately similar to the actual weight of the ox. So that is what we are trying to implement in the case of ensemble model as well, where we are combining multiple weak learners to create one strong learner. Okay, instead of directly creating a classification model and trying to create a good classification model, what we can do it, we can combine multiple weak learners to create one strong learners. Now, what is a weak learner? First of all, this question must be there. What is a weak learner? How do you know that a learner is a weak learner? So a weak learner is something which is performing somewhat better than random guessing. Okay, random guessing. If a model is performing random guessing, then the weak learner is performing somewhat better than that model. That is called as weak learner. So what is the main idea behind ensemble learning is you are combining multiple weak learners to create one strong learner in the case of decision in this ensemble learning model. And we will study ensemble learning in context with decision tree for the time being. Okay, so I suppose that basic idea behind the ensemble learning is clear, right? The basic idea is clear to everyone? Okay. All right. So, yes. Okay. So, fine. So, can you point out one of the point that is required in creation of the ensemble learning model? Okay, so I have shared with you the basic idea behind ensemble learning, where we'll be combining multiple weak learners. Okay, so what are we trying to do? So for example, multiple weak learners we are trying to combine and we are creating one strong learner. Okay, that is what we are doing here. And what is the main idea? So for example, suppose you are doing a movie review. Okay, suppose you are doing a movie review. Let us take an example of a movie review. And suppose most of the participant if gives one as an answer that it is a good movie. Suppose one is an answer that it is a good movie, and -1 denotes that it is a bad movie. Okay. So for most of the if most of the classifier, most of the learner gives answer as 1, then the final output based on max voting. Okay, one of the method to combine this model is max voting. So based on max voting, you can say that the result is 1. And suppose here this is a classification problem. Okay, this is a classification problem in which we will be implementing using max voting. And in case of regression, what we can do? We can take mean of the result, mean or average of the result that we are obtaining. So for example, suppose we are combining multiple learners to predict the price of the house. Okay, predict the price of the house. So what we can do, so suppose we have combined 5 different learners, 1, 2, 3, 4, and 5 different learners, and they are predicting certain values. For example, value 1, 2, 3, 4, and 5. These are the values that is predicted by 5 learners. So in the case of this, what we can do, the final result will be average of all the results obtained by different learners. That is will be average. So whenever I'm talking about learner, I'm actually talking about different algorithms that we can use. For example, a particular learner could be SVM. SVM is one of the learner that we can use. Decision tree is another learner that we can use. We can use linear regression as one of the learners. So different model, different learners, you can pass the same data in different learners, and you can check that what is the prediction of that particular the learner. Okay, and then the final output will be combination, that is average of all the output that you are obtaining. This is one of the way where you can combine the different learners to get the output. In the case of ensemble learning, one of the method is max voting. Max voting, that is in the case of classification model. Whenever you are using classification based data that you have, you can use max voting to estimate the output in the after performing ensemble learning. And the second one that we have is average. You can do average of the all the outputs that you can use. Okay, is this clear? Is everyone clear with these 2 points in the case of max learning, max voting and average? Okay. Okay, can you point out that what is one of the problem? What is one of the point that is highly necessary in the case of ensemble learning? Okay, so I have told you different points regarding this. So first thing we discussed is we are combining multiple weak learners to create strong learner. Then we saw that we can use max voting in the case of classification based problem, and we can use average of all the values in the case of regression based problem. So what is one of the point that is necessary to make the ensemble learning output to be better, okay, better than the original classification? So for example, if you are using a single classification model, okay, you are creating a single classification model decision tree and you are predicting the output, or you are using ensemble learning model to use perform the implementation on the same data. So what is one of the thing that is necessary that you seen that you think is necessary in the case of ensemble learning model to make this one as a strong one? Okay, somebody has given input. If some learner predicts very large value. Okay, yes, normalization is required, right? Any other point that you point out that is necessary in the case of ensemble learning? Any other point? Also, there is something called weighted average. General, in that case, we also have weighted average where we'll be giving certain weights to, for example, in the case, if you relate this to normal analogy. So, for example, in the case of movie review, we can give higher weight to the critics review in the comparison to some of the normal people, normal individual, right? So, that is also one of the case where we are using weighted average. Okay. So, can you say that diversity is important in the case of ensemble learning model? Can you say that diversity is important in the case of ensemble learning model? Are you able to relate why diversity will be important? Okay. Okay, let me tell you. Fine. So I'm just now one of the important thing in the case of ensemble learning model is diversity. What do I mean by diversity? First of all, so diversity is, for example, if you are combining multiple weak learner model and all of them are facing the same overfitting issue. Okay, so also one of the things that you have to see in the case of weak learner model. So for example, just consider that this is some multiple weak learners that we have, and suppose first weak learner is performing is having a problem in classifying a sample 1 and 2, and second weak learner is having a problem in classifying 3 and 4. Okay, so you can say that if you are combining these two weak learners, then it is possible that the output will be optimal. Okay, because first learner is having error in some other cases and second learner is having error in some other cases, so that there won't be an issue here. And while in the another case, for example, if both the weak learners, suppose 1 and 2, both are performing bad in the case of 1 and 2 itself, then 1 and 2 will not be there in any of the classification result, yes or no? So can you say that diversity of the model that we are combining is very important in the case of ensemble learning model? Then only the model that you are creating using multiple weak learners will be optimal, or it will perform better than a normal classification model that you are creating. Okay, otherwise it won't give you better result in the comparison to the normal classification model. Are you getting this? Why diversity will be important, will play an important role in the case of ensemble learning model? Yes. So is everyone getting this idea? Okay, so one of the things that is important in the case of ensemble learning is diversity. Okay, okay, multiple models. So for example, if you are combining multiple weak learners, then these weak learners should be bad in some different cases. Okay, they should be diverse. So for example, first weak learner can be performing bad in some other samples, while second weak learner could be performing bad in some other samples. So that is the case. You need diversity in order to achieve a good ensemble model. Okay, a good ensemble model will be achieved if you have higher diversity. So what are the things, what are the cases through which you can achieve diversity? What are the cases you can achieve diversity? Can anybody point me out? What are the cases through which, what do you think could be the cases through which you can achieve diversity in seed randomness by splitting the data? Okay, we are coming to that point. Yes, randomness is right. Randomness. Any other?